Welcome to qnawire.
In this question, we are told that if the molar solubility of calcium fluoride, so we have calcium fluoride at 35 degrees Celsius is 1.24 times 10 raised to power minus 3 mole per liter. We are told to calculate the KSP at this temperature. So we know that KSP is equals to calcium fluoride, Ca2 plus, and F minus raised to power 2. So this is what we are looking for. Now, if we have calcium fluoride we dissociate to produce Ca2 plus aqueous plus 2F minus. So if we write the equilibrium expression for this, it will be the product concentration divided by the reactant concentration. So that's going to be calcium 2 plus concentration multiplied by fluoride ion concentration square divided by calcium fluoride solid concentration. And this is solid. So because solid, we assume it's 1, or we equate it to be equals to 1. Therefore, the K equilibrium will be calcium 2 plus concentration multiplied by fluoride ion concentration raised to power 2. Therefore, KSP would then be equals to, the concentration of calcium fluoride is 1.24 times 10 raised to power minus 3. And this will be equal to the concentration of calcium 2 plus, because 1 mole of calcium fluoride will produce 1 mole of calcium 2 plus and 2 moles of fluoride ion. Therefore, KSP expression written out here will be calcium 2 plus concentration, which will be the same thing as this, multiplied by the fluoride ion concentration, which will be the same thing as this, but raised to power 2. So this will be 1.24 times 10 raised to power minus 3 all squared. So what would this give us? This will give us 7.63 times 10 raised to power minus 9. And the unit will be mole cube per liter cube. So that's the answer. Now, the next question, this is A, okay? This is A. This is A. Now let's go to B. For B, it says we should calculate the KSP for strontium fluoride, given that we have 1.1 times 10 raised to power minus 2 grams of SRF2 in 100 ml of aqueous solution. So the first thing we need to do in this case is to determine the number of mole that this 1.1 times 10 raised to power minus 2 grams of strontium fluoride will be equals to. So the molecular weight of strontium fluoride is 125.62 grams per mole. Therefore, the number of mole will be equals to 1.1 times 10 raised to power minus 2 grams divided by 125.62 grams per mole. And this will give us This would give us, say, 1.1 times 10 to the power minus 2 divided by 125.62. This would give 8.76 times 10 raised to the power minus 5 mole. Okay, so we can then calculate concentration because we are given the volume. So, but we need to convert this volume to liters. So this would be 100 divided by 1000, because 1000 milliliters is equal to 1 liter. Therefore, 100 milliliters would be equals to 0.1 liter. Okay, therefore concentration will be equals to number of mole divided by volume in liters. So this would be 8.76 times 10 to the power minus 5 mole divided by 0.1 liter. And this will give us 8.76 times 10 to the power minus 4 mole per liter. Okay, so now that we know the concentration, so we know if we have SRF2, it will dissociate in aqueous solution to produce SR2 plus aqueous plus 2F minus aqueous, right? So if we use the high stable or high setup, initially we started with this is 8.76 times 10 to the power minus 4, and we had this 004 amount of strontium 2 plus and F2F minus that's present. Then we use this up because it dissociates completely, and we will produce 8.76 times 10 to the power minus 4 mole of this, and we will produce 2 times 8.76 times 10 to the power minus 4 mole. Okay, so the amount at equilibrium then will be 8.76 times 10 to the power minus 4, and this will be 2 times 8.76 times 10 to the power minus 4 mole. All right, so we know KSP is equals to SRF2 SR2 plus concentration multiplied by the F minus concentration. So that's F minus concentration all square. So this would then be equals to SR2 plus concentration is 8.76 times 10 to the power minus 4 multiplied by F minus concentration is 2 times 8.76 times 10 to the power minus 4, and then you square it. So what would this give us? 8.76 times 10 to the power minus 4 square times 2 square times 8.76 times 10 to the power minus 4. So this will give us 2.69 times 10 raised to power minus 9. Okay. Right, so let's move to the next question. The next question says that we have barium iodate. So this is C. You have barium iodate. And we are given the KSP of this to be 6.0 times 10 raised by minus 10 at room temperature. So we know barium iodide, when dissolved in aqueous medium, will dissociate to produce barium 2 plus aqueous and iodide ion, IO3 minus, but we have two of it produced. So if we are to write the expression for the KSP will be equals to BH2 plus concentration multiplied by 2 times iodide minus concentration all squared. So from this, we can assume that IO3 concentration is equals to BH2 plus concentration. Okay, so if that's the case, then we can write the KSP expression by substituting BH2 plus in place of IO3 minus. So we're going to have BH2 plus multiplied by 2 multiplied by BH2 plus all square. Now, we know that the KSP is 6.0 times 10 raised to the power minus 10. So the 6.0 times 10 raised to the power minus 10 would then be equals to, so if we simplify this expression, this is 2 squared is 4, and be it the 2 plus square, the be it 2 plus square. So we're going to have this expression to all simplify to be 4BA2 plus square. And we have BA2 plus here. So if we multiply it, we'll have 6.0 times 10 to the power minus 10 will be equals to 4BA2 plus cube. Okay, so divide this by 4. So 6.0 times 10 to the power minus 10 divided by 4 will be 1.5 times 10 to the power minus 10 is equals to BA2 plus cube. Okay, let me just put this in brackets. So then we need to find the cube root of 1.5 times 10 to the power minus 10. So to determine the concentration of BA2 plus will be the cube root of 1.5 times 10 to the power minus 10. And that will be 5.313 times 10 raised to the power minus 4 mole per liter. So this is the answer.